We're now going to discuss Chapter 19, Costing and the Value Chain, and we start with an example from Kimberly Clark, noting, and Kimberly Clark is a maker of well-known personal care products that you'd find in, Walmart or Amazon or whatever. But they shifted their strategy from basing store shipments on historical sales forecasts to shipments based on point of sale data. Point of sale, like immediately, like how much are we selling last week? How much are we selling at this store, at this place, and immediately fulfilling that. And it was a change in their emphasis and what they're trying to do in order to save costs and save waste and reduce the amount of inventory on hand. So they use transportation management solution software to create a more efficient delivery route. And that resulted in savings of over $1 million per year. And not only savings for them, but also reducing the emissions that were being made. This is just a small part of what they've tried to do to reduce packaging, recycle appropriately, reuse waste products, and manage cost across the value chain. And that's what we're going to be discussing today. So in this chapter, we're going to emphasize the value chain. What activities create value? And we're going to emphasize these four components of the value chain. R&D, research and development that develops new products and processes and services. Relationships and interactions with suppliers and production-related activities. All activities needed to convert products from raw materials to finished products. Marketing and distribution activities, trying to provide information to potential customers and make that accessible to customers. And then customer service activities, typically after the sale. Now, we're interested in kind of divvying up these activities between those that create value, meaning are you willing to pay more for it? And those activities that don't really add to the product desirability and don't really affect the value. So some things matter, the value added activities, some things do not. And so as an example, assume you're a manager of raw materials for a lumber mill. What type of resources are being consumed when a large amount of redwood log sits idle, waiting to be put through the mill? Okay, so the question is, if they're sitting there, are they creating value? Well, let's think about it for a second. The company forgoes customer sales as redwood logs sit idle prior to being processed. If they're sitting there, they're not being sold, right? Also, there's cost, there's land, and they're just sitting there, and they use capital, their inventory that is invested in, but not being invested. So the investment really is in the logs rather than paying back a loan. And so you can see how that might be considered. So let's take a look at this. The ones up top here are those that create value. The ones at the bottom here are the ones that do not create value. And so we can see that these are the four activities we just talked about: the R&D, interactions with suppliers and production, procurement, marketing and distribution, and then customer service after the sale. And so let's just look at these value-added activities. Designs that meet customer specifications, yes, that would create value. Use of suppliers that provide high-quality inputs and timely. Production process that provides just-in-time output for customers. Timely distribution. Clear and truthful marketing, and competent and timely after-sales customer help. So we can see those that create value. Which ones do not? Well, designs that meet engineering specs but not customer needs. I mean, we've got to sell it to the customer, right? So if it's not meeting their specs, then not creating value. Supplier deliveries that are poor quality. Yeah, that definitely does not create value. Production process that create rework, scrap, and significant work in process. Significant work in process inventories. Delayed distribution to customer. Deceptive or misleading marketing. Clearly, that's not going to create value. After sales customer help that is not valued by customers. Okay, so we see some are creating value and some are not. So as we think about this, we're going to talk about activity-based management and see how it syncs up with our activity-based costing. So activity-based management refers to the process of using these activity-based costing to help reduce and eliminate non-value added activities. The basic procedure related activity-based costing that we covered in an earlier chapter are to identify the activity, create a cost pool associated with that activity, identify an activity measure, and create the cost per unit of activity. Okay, and so these can be applied to activities across the supply chain. Now, when we talked about activity-based costing earlier, in an earlier chapter, we were talking mostly about production costs. But these costs apply to all or most of the activities being done by the firm, such as R&D, distribution, administration, finance, marketing, and customer service. So we can use those same procedures, looking at cost and cost pools and activity drivers, cost drivers associated with each of these. So to illustrate how activity-based management works, consider Boards and More. Boards and More sells lumber, and Boards and More has been approached by a vendor of a software package designed to reduce the cost of processing transactions. In order to determine the cost savings, the CFO has decided to undertake an ABC activity-based costing study of activities in the accounting and finance department. Okay, so all right, what activities are performed by this department? Well, there's 4. Transaction-related activities. For example, an invoice comes in, invoice needs to be paid. External financial reporting. Okay, so we've got to accumulate this information, make journal entries, and see how it affects the financial statements. Annual planning and budgeting, okay, and then special request projects. And to do this work, we have 12 clerks at $20, 5 finance analysts at $45,000, 6 budget analysts at $39,000, 3 senior analysts at $75,000, and the CFO at $185,000. Okay, so we can see what activities they perform and what the costs are. And so let's go and look at these. Okay, what are the activities? We determined there are transactions, financial reporting, planning and budgeting, and special requests. And these are how each of the 4 labor cost pools, the clerks, the analysts, finance analysts, budget analysts, and senior analysts and CFO spend their time. So the 12 clerks spend 75% of their time on transactions, 12.5% of their time on financial reporting, and 12.5% on planning and budgeting. Whereas the senior analysts and CFO spend their time on financial reporting, 25%, 25% planning, and 50% special request projects. And so we can see how this divvies up in terms of their time. All right, now let's take it one more step and we'll see how this shows up and how costs are expended. So you may want to stop this presentation and look at this really carefully here to see how this goes. But here are our 4 labor categories. Here are our 4 activities. And we can see based on the time spent, so the clerks make $441,600, right? And they do much of the detailed work. And this is how that is allocated among these activities. And we can see that for each of these groups, how it's allocated and how much money is spent on each of these processes. We can see what that looks like here. And so we see 1.3 million plus some change is spent on these various activities. Okay. So as you recall, we're trying to evaluate this software and see how much time it saves, how much cost it saves. The quoted price of the software is $450,000 for a fully installed package. The CFO purchases, if the CFO purchases the software and the vendor savings estimates are correct, the initial cost of the software will be recovered in approximately 2.22 years. So let's go back and look at this. Where does this $406,200 come from? Okay, so 406,200, that's in transaction related, and it believes it can save 50% of that. Okay, and so that would reduce the transaction cost to 203,100. So we could take the 450,000, the quoted price of the software, divide by 203,000 per year, and determine it takes 2.22 years to recover that investment of that cost. So the CFO has many concerns. I mean, it's not all just cost. If 9 clerks are engaged in transaction related activities, she must consider whether half of them will need to be fired. Well, how's that going to help morale at the company and what they're doing? Is that what they want to be doing? Are there legal and ethical implications to that firing? The CFO may also conclude that the estimated 2.22 years required to recover the investment is too long because software is consistently changing. And if we wait 2 years, then maybe there'll be a better product after that time. So we see this detailed analysis determines, clerks versus analysts, who's going to be affected, and we may want to do additional analysis. So as an international case in point, a broad group of global companies, General Dynamics, Target, Dell, Whirlpool, etc., are searching for graduates in global thinking about supply chain management. But note the activity-based cost management, which is exactly what we're talking about. Value engineering, where value is created, divvying up between value added and non-value added activities. And so we can see, what this looks like and why it's important. And so consider the following job description. The desirable candidate will be responsible for the identification, development, and implementation of global sourcing strategies. And so has that background. Okay. So duties also include interfacing with all facets of supply chain management, from manufacturing, engineering, quality, and has these various skills, including activity-based costing, negotiation skills, ability to interface seamlessly with all levels of the organization, etc. Well, and note the exposure to value engineering and value analysis. And so really understanding how value is created. So let's talk a little more about the target costing process. So target costing focuses on the earliest stage of product development. Okay, so from the very get-go, we're saying, hey, we want to target a certain cost. Okay, it is a process driven by customer expectations. They're the one that's going to receive the product, and they need to have certain qualities, characteristics of this product. So the objective of target costing is to create a production process that provides adequate profits. So we're going to focus both on the profit and cost planning over the entire value chain. That means all the interactions and ability to tap synergies across the full value chain. Okay, so what are the components? Well, if we have a target cost, the desired cost, target cost, is the cost resources that should be consumed. Okay, so the target costing process begins with determining an appropriate target price. What will consumers pay for this? Okay, so we're going to do some market analysis, look at competitors, have interactions with consumers, and determine the appropriate target price. So notice an important component of the target cost is what price can be charged. Then we want to have an acceptable profit margin. Okay, so we want to make some money, and it's got to be a certain percent to get to our target cost. That'll be the difference between the target price and the profit margin. So components of target costing. Okay, so there are 4 here. Planning and market analysis. Okay, can we set the right price? Can we understand our competitor, understand our customer? Concept development. So we're gonna come up with a concept. That often in automobile, they say, here's a concept car, right? That has these various characteristics. Then production design. Once we have a concept, then we've got to figure out how to get it in production and figure out how to do it considering cost from the start, and then production and continuous improvement. So those are the 4 components there. So as we're illustrating using Boards and More's product line, they're creating a cardboard packaging for various products. The company bids on packaging jobs for such products as laundry soap, cereal boxes, and light bulbs. The value chain for these packaging includes R&D to create cardboard with superior quality and strength at the lowest possible weight. Okay, so they're trying to do this at the appropriate cost level, but has superior quality and strength. All right, so Boards and More produces the cardboard in large rolls that are shipped to suppliers for printing in a box formation before the box are shipped. So let's see what that process looks like. So here's the R&D, right? We figure out the appropriate mix. It's got to have certain qualities in terms of fiber mixing, pressing, and heating and drying. Then we ship it out to the printing supplier and the cut and bend supplier, to get it so it's printed, and now it's shaped back into the appropriate cardboard packaging, distributed, goes to the soap manufacturer, to the retailer, to the consumer, and then finally it's disposed. So we can see that. And as we're looking at various components, we can see, okay, here are the soap consumer requirements as well as the soap manufacturer requirements. And so we can see various characteristics of these. So we can see these requirements here. Box has to be easy to pour, ink does not bleed when wet, box is lightweight for shipping, and box is strong for filling. So we note the ability to bend and cut the cardboard is very important for how easy the box is to pour, its weight, and its strength. Unfortunately, although the lightweight material is easier to bend and cut, and it's easier for the consumer to pour, it often is not strong enough to meet the soap manufacturer's requirements, as noted here. It seems clear in the exhibit here on this slide that if the box could be made stronger while simultaneously maintaining light weight and high absorption, several consumer requirements would be met. Of course, this might be more expensive, and so we need to consider additional costs associated with this lighter weight material. Okay, so this tells us what we need to have. Now let's talk on the cost side. Laundry soap consumers are unwilling to pay more than the current retail price of $8.50 per box. The soap manufacturer is unwilling to increase the $1.16 price per cardboard box it currently pays to Boards and More. Okay, so competitors are close to releasing new plastic containers, but the engineering managers at Boards and More are skeptical that these plastic containers will be acceptable because of pouring issues. So, all right, so we have kind of set out what the constraints are here. Okay, so we see our current activity-based cost among these various solutions is 61 cents. That's what we're at currently. Here is our initial target cost of 66 cents, but we went back and said, okay, how much are they willing to pay and how much is our margin? If we could get a better value engineered target, something they would like, and keep with the existing cost structure, that might be a win-win. All right, so we also need to think a little bit about life cycle costing, and those are the potential resources consumed by the product over its entire life. Not just from the start, right? Not just the product development and R&D costs, but all the costs through warranty and disposal costs. And so we need to think about all the costs over the life cycle. So as characteristics of the target costing, the entire value chain is involved in driving out cost. Okay, so we're all working on that process. We got to understand the process in order to get at that target price. Okay, the target costing requires an emphasis on the product's functional characteristics. Okay, so if we're trying to create value and maintain and hit a certain cost, then we need to be working together and really focus on those characteristics that are important to the customer. Usually, an objective of the target costing process is to reduce development time, and ABC information enables managers to better determine which process changes will drive costs out of the activities necessary to achieve the target cost. Okay, so let's talk for a minute about just-in-time. A just-in-time manufacturing system is one approach. So just-in-time means that the inventory shows up and is able to be produced just in time. Is totally driven by customer demand. So we see how many are sold at this Walmart at this price at this time, and we immediately go and work to quickly fill that just in time. Okay, instead of a more traditional supply push system where we say, here's all these products here available for you. We made them months ago. And we produce as many as we can to lower the cost. We're trying to figure out how to get it there just in time. So a just-in-time system is characterized by really small inventories, really small raw materials, really small work in process, really small finished goods. Materials are scheduled to arrive only as needed. Okay, so products flow through. You see what's sold, and then you immediately fill the next step. Finished goods in excess of existing customer orders are not produced at all. And so we're trying to reduce waste and eliminate costs associated with storing inventory. So let's talk about how this would work. It's the demand pool production. Okay, this is how many they have ordered, and it requires on-time delivery to those customers. The factory goal means, hey, we've got to reduce all this process time, and we've got to really increase quality. And so we're going to be working through that. Okay, and this requires that the supplier delivers exactly what we need on time, that information is shared, and have all the information we need in order to have high quality on-time delivery. So a successful implementation of JIT system generally requires a limited number of suppliers, those that are able to work with us, that are able to shift quickly from one product to the next, and a very efficient plant layout where we could say, hey, we're doing this product today, we're doing this product tomorrow, and an efficient plant layout to allow that to happen quickly. All right, so next let's talk about cycle time. Cycle time is length of time required for a product to pass completely through a manufacturing process. Okay, so notice these various times. Processing time is the only one that creates value. The storage and waiting time, the movement time, and the inspection time don't create value, but they are part of the process. And so we've got to eliminate or reduce the amount of storage and waiting time and movement time and inspection time as we can. And we have a ratio here called the manufacturing efficiency ratio. And this ratio says, let's compare the value added time, typically, this processing time, if that's the one most likely to create value, and divide that by the total cycle time. Now, we're never going to get to 100%. That would be ideal. That would be optimal, but it's usually well below. But this is something that we can track, is this cycle time. Remember, we're trying to get efficiency in the process, and to get that efficiency requires reducing cycle time. All right, so how do the accounting systems help? Well, accounting systems help by measuring quality, the defect rates, how many returns there are, how many claims there are on warranty, how many customer complaints, and then just basic customer satisfaction. It seems like we're always asked to fill out that information. So let's talk about these various quality measures. As we talk about these quality measures, we talk about them in terms of the cost, the prevention costs. Like if we made this from the get-go high quality, that would save us a substantial amount through the process. How are we going to get that? Through employee training, through quality process audits, including quality control costs from the get-go and the target costing, and then especially as we evaluate the quality coming from customers. So first is prevention. The next is appraisal. Okay, we've got to determine whether it meets our specs. And so we're going to inspect the incoming materials from our supplier, the products that are in production, and those in finished goods inventory, monitoring the production process, and maintaining testing equipment to ensure quality. Okay, so that's the second type of cost. The third cost, internal failure costs. Okay, so if we have got low quality production related costs, then we got to rework flawed products. We have downtime as we fix the equipment. We change part of the process to take care of the defects and the disposing of scrap. Okay, so that'd be the internal. And how about the external? Well, if we don't make high quality products, we're not going to be able to sell them. We've got to now process the returns. We've got to pay for warranties, product liability costs, and diminished goodwill with our customers. So we can see what those costs look like. So we've just talked about 4 costs, and there's kind of a trade-off among these. So here's the costs of quality, and here are the various components. So we talked about prevention and appraisal, and we talked about external and internal failure. And so we can see there's kind of a sweet spot in here where we want to produce. I mean, if we, spent all of our time and effort trying to get rid of various, costs, well, that would require a lot of prevention and appraisal to make sure it's all done right. But that would mean there was less external and internal failure. But there's going to be a sweet spot. So this is the combination of all costs. And so we'd like to produce somewhere down here where the trade-offs make sense and total cost of quality is smallest. So let's talk for a minute about Six Sigma. So sometime you'll hear about Six Sigma within a manufacturing process, and this works to address quality. The main concept here is looking at how many defects you have in a process. And then you can figure out how to eliminate the defects. And so there's a process, there's some techniques used to improve business and manufacturing processes, and that's called Six Sigma. So as you read about that, you'll see how that's used within a manufacturing context typically. Okay, so back to boards and more. Here are the 4 types of costs: our prevention costs, our appraisal costs, our internal failure costs, and our external failure costs. And you can see how those are summed up in each of those. So here's the sum of each of those, and here is the percentage of sales. So here's how much of our costs, our cost of goods sold, is essentially costing us. So 10.4% of sales. That's what is spent on this. And the question is, can we reduce that?